All right, we are back with another example with pre-calculus stuff, getting ready for calculus. And this time around, we're trying to solve for x. We have 3 times the natural log of 5x plus 4 equals 21. So when you're solving equations, we mentioned this before, and when we were solving sines and cosines in the different video, if you think about that 21 not being there, if that 21 were gone, we'll put it back in a second. If that 21 were gone, and I ask you to evaluate this, I say what happens when x is equal to 9. The first thing you would do is you would first multiply by 5. Then after you multiply by 5, you would add 4. Then after you added 4, you would take the natural log of that answer, and then finally you'd multiply by 3. All right, those are the steps if you were to evaluate this. So when it comes to solving, you have to take each one of those steps and do it in reverse and do the opposite operation. So the first thing I'm going to deal with is the 3, not the natural log. Then I'll deal with the logarithm. Then I'll deal with the 4. Then I'll deal with the 5. So making this thing back to equals 21. The first thing we said we're going to deal with is that 3, so we're going to divide both sides by 3. In doing so, this 3 and this 3 will reduce down because opposite of multiplying is dividing. That leaves us with the natural log of 5x plus 4. And on this side, we get 7. Now we have to deal with the natural log. That list that we just had over there, that was the next step, reading from the bottom to the top. So you have to do the opposite of taking the logarithm of something. So what's the opposite of a logarithm? It's called exponentiating. In other words, what essentially we're doing is we're going to rewrite this entire logarithm as it is for a base to a power. Remember this little fact, the fact that if you have base to a power equals a number, as a logarithm what that means, log base b of n equals p. All right, we have that fact. That's something that we can translate back and forth. And then finally we want to remember that ln really is log base e. That's all that we have. So this is log base e of 5x plus 4 to the 7th power. That's what we got going on. So our base is e. So I'm going to write that as my base. What the logarithm equals, that's the power that goes on e. And so this is e to the 7th. That's going to equal the number, or n, the thing that you're taking the logarithm of, in this case 5x plus 4, and so that's going to go here. You are essentially exponentiating. Off to the side, the other way that you can think about doing this is you are simply making each side a power for e. So you're having e to the natural log of 5x plus 4, and that's going to equal e to the 7th. Right? I'm doing the same thing to both sides. I'm making both sides, because both sides are equal. The natural log of 5x plus 4 is equal to 7, so I'm making both sides an exponent on e. That's totally allowed. And so I can evaluate this e to the natural log of 5x plus 4. The way that you think about it, the way that other teachers have taught you, the way that your brain processes it, is that e and the natural log cancel out, which is not really true, because if e and the natural log canceled out, you'd be left with 5x plus 4 as an exponent, which is not true. 5x plus 4 is no longer an exponent. This fact, that is a fact, an exponential fact, which works due to what we know about logarithms, is that e to the natural log, because they are the same base, e to the natural log of 5x plus 4 is 5x plus 4. So it's not magic. It's not that it cancels. You can think of it that way, but that's not exactly what's going on. But as long as you understand that that's what happens, then you've got this e to the 7th equals 5x plus 4. From here, it's super duper easy to solve. You need to get rid of two different things. You're trying to solve for x. You need to get rid of the plus 4. So to get rid of the plus 4, you can simply subtract that from both sides. So we'll have e to the 7th minus 4. That will equal 5x. And then you want to get rid of the 5. So dividing both sides by 5 and writing it the normal way, because that's order, not chaos. X is equal to e to the 7th minus 4. All of that is over 5. Now, this is totally fine to leave as an answer. This is actually the exact answer, and most of the time I will want an exact answer, but on the worksheet that you're working on, usually on a test, I'll ask you what's the decimal equivalent or round this decimal, and so all you got to do is punch it up on a calculator, and the decimal equivalent is 218.53 if you're rounding to the nearest hundredth. And so either answer is fine. Like I said, I usually prefer the exact answer over the decimal, but whatever answer you want to give me, if I ask for, actually not whatever answer you want to give me. If I ask for decimals, give me decimal. If I ask for exact answer, give me exact answer. That's how you solve any logarithm problem.